Hi guys, happy Wednesday. We meet again. This is our July week 3. Oh, sorry, week 2. Brain fart, sorry. Oops. So anyway, so how are you guys doing? Hi Jella, hi Kavi, hi Gabriel. How are you guys doing? So we are continuing with our chapter 6 from last week, and I shall wrap this chapter up by today, hopefully. Right, so guys, do you remember what have we learned so far? Do you remember what have we learned so far? We have learned what is your electrolytic cell. Okay, do you remember the SOP? What do? We look for the word solution, we say H2O, we split, guys on the left, girls on the right, guys on the left, girls on the right. So we have two guys swimming in water, two girls swimming in water. And according to situation 1, according to this situation 1, we always choose the ugliest guy, we always choose the ugliest girl and kick them out of the water. Remember? Do you remember this, guys? Do you remember this? I hope you do. Okay, and then situation 2, when we talk about concentration, we still choose the ugliest guy, but we choose the slightly higher girl, right? The red box, slightly higher girl. Okay, chloride, bromide, and iodide. This is situation 2. Remember this? And I did mention situation 3 last week, isn't it? Situation 3. So situation 3, we still choose the ugliest guy, but for the girls, we choose neither. We don't choose any girl, but instead, the silver will jump into water. I kick silver out here, okay, because silver is positive, cation. It will be pulled to the cathode, and you will see a layer of silver sticking here, right? And then you have silver jumping into the water, so this thing will become smaller. It will be corroded. Guys, do you remember this? Do you remember this? Hello? Is everyone there? Do you remember this? 3 situations. First situation, both sides choose the lowest. Situation 2, if it's concentrated, guy follow the lowest, which doesn't change for guy, girl choose higher. Third situation, guys still choose the lowest, but we don't choose any girl, but instead this will jump in. Remember this, Remember this, And remember, I said situation 3 is the most useful because we use this in electroplating. Okay, we use this in electroplating and we use this in purification. Okay, we use this in electroplating and we use this in purification. Okay, we put the one at negative. Okay, we put one at negative so that the silver can stick here, or we put the impure copper at the positive so the copper can come out. I'm only extracting copper. You do remember this, You do remember this, Because later, right, situation 3, we are applying it in chemical cell. Because so far what we have learned, guys, the 3 situations we have learned, we are still learning electrolytic cell. We are using electrical energy to change into chemical energy. We are using batteries. Are you listening? We are using batteries. To create chemical reaction. Okay, you see? Battery chemical reaction. And then battery chemical reaction. Battery chemical reaction. Battery chemical reaction. Situation 2, battery chemical reaction. Situation 3, battery chemical reaction. Okay, later, electroplating. Electroplating, okay, you see, silver will stick to negative, right? Silver will stick to negative, right? So if I put a spoon here, silver will stick to my spoon. Now my spoon has a layer of silver. Electroplating. Do you understand? I coat a layer of metal on it. That's all. It's just like painting. But this is a more effective painting. Right? If it makes any sense. Okay, guys, before we move on, can we please go and do some exercise? Let's do some exercise. Okay, let's do some exercise. Guys, have I give you any homework? Did you do question 8? Page 20. Page 20. Have you done this? Have you done this? Okay, if you have, right? Then let's discuss question 8. Okay, so let's look at the water first. Okay, you have 2 sets of electrolytic cell here. Okay, let's look at the water first. So again, according to our SOP, solution H2O. Remember? Then cut. Okay, cut. Positive, negative. You have 2 guys swimming in the water. You have 2 girls swimming in the water. Right? You have copper and hydrogen, the guys. You have sulfate and hydroxide, the girls. You remember what is hydroxide? Okay, hydroxide, the girls. Right, guys, I have a question here. For this set, for set P here, is this situation 1 or 2 or 3? 1 or 2 or 3? Come, answer me. 1, very good. Kavi, how do you know it's 1? How do you know it's 1? From what you can tell it's 1? How do you know it's 1? No concentration, very good. And the 2 sticks are carbon. Okay, then what about situation 2? Oh, sorry, it's not this one, Q. What situation is this? What situation is this? Just now the one is 1, right? What is this? What is this? No, it's not 2. 2 is concentration. You see, guys, the 2 stick is copper. The water is also copper. Copper. So this is situation 3. Right? So I will not choose any girls here. Instead, copper will jump out. Copper will stick here, copper will jump out. So this thing will become thicker, this thing will become thinner. Remember, this is situation 3. 1 jumps out of the water, 1 jumps into the water. Ken, do you understand? Do you understand? What to do with the rods? You mean these 2? You mean these 2? Because you see, copper. As long as your rod and the water guy, the guy in the water is the same, copper, silver, then that one for sure is situation 3. Carbon, we don't care. Carbon will not take part. They will just stand there and let the guys jump out, let the girls jump out. That's all. Carbon will not take part, but copper will. Copper will jump into the water to replace the copper. Does it make any sense to you? Okay, guys, we skip A. I'm not going to talk about the meaning of electrolysis. This one you go fill it yourself. I'm not going to do definition here. Okay, so B, state all the ions present in the aqueous copper sulfate solution. Who are the boys and girls inside here? Who are the boys and girls inside here? So we have copper ion. Okay, this is the first guy. And we have hydrogen ion. Yes, good. That's the second guy. And then the girls, we have sulfate ion. And we have hydroxide ion. Okay, sulfate ion and hydroxide ion. Cool? You guys cool? Yes, cool. So 2 girls, 2 guys here. 4 marks. Okay, 4 marks. Hey guys, if you can answer this question, that means you really understand. Okay, I know it sounds like a very simple question to you, sir. Only 2 guys and 2 girls. What's so hard about this? Hey, if you can write this, that means you really understand already this chapter. Not fully, but as you're halfway there. Okay, so name the ions discharged at the anode and cathode for the following electrolytic cell. Okay, let's look at P first. So we have anode and cathode. Guys, I like to make it a habit. Anode is positive. I like to write beside here. Cathode is negative. Just in case, you might say, sir, I already know. I don't need to write. I know you already know. Even, guys, I've been doing this for 12 years. I already know too, but I still write it. It's a habit. It's a habit. You don't get confused. You see, this is another positive. Cathode, negative. Right? So positive is going to attract negative, right? Okay. Anode will attract anion. So this is situation, P is situation 1, right? So who will be chosen? Which girl will be kicked out of the water? Which girl will be kicked out of the water? Anyone? Anyone? Which girl will be kicked out? Yes, your hydroxide ion. Good. Okay, your hydroxide ion. What about cathode? What about cathode? Copper or hydrogen? Who will be chosen? Who will be chosen? Who is the uglier guy here? Who is the ugly guy? Uglier guy here? Is it hydrogen or is it copper? Yes, copper. Good. So copper ion will be chosen. And electrolytic cell Q, anode, positive, cathode, negative. So which girl will be chosen for situation 3? For situation 3, which girl will be chosen? Which girl will be chosen? Come, test your memory. Which girl will be chosen? This is situation 3. Think properly. Situation 3. Right? Situation 1, we choose the lowest girl. Situation 2, we choose the higher, slightly higher girl. Situation 3. What about situation 3? We choose. No. Copper is here. Copper is here. I'm talking about the girls. The girls. You see why I want you to write down now? Hey, copper come here. Copper is gay, you know. Copper is a guy. Anode is a guy. Will guy attract guy? Will guy attract guy? There's no gay in chemistry, right? So anode will attract negative. Which girl will be chosen for situation 3? Which girl will be chosen? None. None. No ions. But instead, copper will jump in. Remember? Silver kicked out of the water, silver jump into the water. Again, silver kicked out, silver jump in. So the same thing happens. Copper kicked out, copper jump in. No girls will be chosen here. No girls will be chosen. This is situation 3. Again, this is situation 3. No girls will be chosen. Do you understand? Gabriel, Jiale, do you guys understand? Hey guys, this chapter is really hard to teach. I already simplified to my best ability. Do you understand? Please say you do. If you don't, I will explain it until you do. Kavi, which part do you not understand? Which part do you not understand? Okay, the third one. Okay, third situation. Okay, this stick is a copper. I'm just gonna write Cu lah. This stick also copper. Inside water, there's copper ion. The 2+ is copper. This is positive, this is negative. For situation 3, copper will come here and stick. Copper will jump in to replace. Because usually, situation 1 and 2, if this is carbon, copper will come here and stick. Hydroxide will come here and stick. I am kicking this guy out. I am kicking this girl out. Now, situation 3, I am kicking this guy out. I am not kicking any girl out. But instead, the guy will jump in. That's your situation 3. That is a situation 3. Kavi, I thought you understand this last week. We put a spoon here and stick here, electroplating. We put an impure copper here, copper comes out, purification. I'm sorry, you have to swallow this. You have to swallow, right? That's the best way I can simplify it for you. Do you understand now? Yes, nothing will go to anode. Yes, correct. Nothing will go here. No girls will go here. There, I said it last week. I put a big cross here. Did you? Did you put a big cross here? Because I did last week. I put exactly a big cross here. Because I said none will be chosen. You see, usually it's the girls change. Usually it's the girls who change. You see, situation 1, we choose lowest. Situation 2, we choose higher. Situation 3, we choose none. But for 3 situation, the guys, we still choose the lowest. Guys will not change. Guys will not change. Don't ask me why. That's the way it is. Don't ask me why. There is no why here. That's the reason. Okay, it is what it is. It's like asking me, sir, why do you have 2 hands? Because I have no 3 hands. That's the way it is, right? Gabriel, do you understand, Gabriel? Are you following? Are you with us? Gabriel, are you there? Hello? Are you there? So no one's answering me. Okay, fine. Okay, so shall we move on, guys? Shall we move on, guys? Go for the cathode, copper. Yes, yes. Always, you see, same situation. I don't care whether it's situation 1 or situation 2, the copper will stick here, the copper will stick here. Can? Like I said, the guys will never change. The guys will never change. I always choose the lowest. I always choose the lowest. I always choose the lowest. And did I say I always choose the lowest? I always choose the lowest. I always choose the lowest. Guys always choose the lowest. Guys will always choose the lowest. Am I repeating myself enough? Am I repeating myself enough? So guys, this chapter is really hard to teach. This chapter is really hard to teach. I hate teaching this chapter because it's so technical. I repeat myself to a point that I'm vomiting already. Okay, so what about cathode? What about cathode here? Anything change for the guys? Anything change for the guys? Yes, copper ion. Guys will never change. Can? Guys will never change. Okay, right? So, name one example of the application of electrolysis in industry which applies the electrolysis concept of electrolytic cell Q. Where do we use this in industry? Guys, where do we use this in the industry? When do we stick things here? When do we take things out? Just give me one example. When we stick things here in industry, what is it called? Not gold plating, we just say electroplating. Yes, I'm not rich enough to do gold plating. What else? What about the opposite? Electroplating is stick things there, right? Now, if I take things out, what is it called? I extract things out. I only want to take copper out. What is it called? Yes, this is extraction or purification. I mean, you say purification, I accept. You say extraction, I also accept. So both, they mean the same thing. Okay, guys, question? Do you have any question? No? No? Okay, good. So let's go to question 9. Let's go to question 9. Okay, guys, can you please try question 9? Can you please try question 9 before I move on? I will give you 10 minutes. Okay. Oh, before I let you do, let us discuss a little bit. Okay, set one here. What situation is this? What situation is here? 2. Good. Kavi, how do you know? Yes, concentration. And it's carbon rod. Can you see? What about set 2? What about set 2? What situation is this? 3. How do you know? How do you know? How do you know it's set 3? Electroplating, whatever. No, we don't say electroplating, okay? Because it's copper. Right? Because it's copper. Okay, Okay, I already give you the tip here. Guys, I'll give you 10 minutes. I'll be back at 6:05. I'll be back at 6:05. Please do it right now. Later, I'll finish this chapter, so please make it quick. Okay, 10 minutes. Okay, guys, are you done? Are you done? I'm just gonna give the answer. I straight give the answer. So anions, I like to put a negative here first because it's the girls. Okay, to remind myself it's the girls. So sulfate ion and hydroxide ion. Okay, did you get it? Cat ion positive. This is your copper ion and hydrogen ion. Okay, got it? So carbon, this is situation 2. Anode is positive. Positive is going to attract negative. So who is chosen? Hydroxide is chosen. Cathode, negative. Who is chosen? Copper is chosen. But hang on a second, guys. Hang on a second. They don't want the ion. They want the observation. Right, Kavi, you got it. So you will see bubbles because it's oxygen. You will see reddish brown deposited. Okay, reddish brown deposit because copper is reddish brown. And then copper here, this is situation 3. Situation 3. Oh, this one, none will be chosen, right? None will be chosen, but you can see the copper corroded because they all jump into the water. They all jump into the water, they are corroded. Why none? What do you mean, why none? Situation 2, situation 3, I'm choosing neither girls. Sorry? Neither. Neither. I see, you got it wrong again. Okay, so this one, same. Same. Guys will never change. For the guys one, it will never change. I still choose copper. I choose copper. All right, Kavi, can I suggest you something? Go and do more exercise. Go and do more exercise. This needs practice, right? If you're not good at it, go and do more practice. That's all I can tell you. Right, so C for the carbon electrodes, which is this second one, second situation one, state what is formed at the anode and the reason. Okay, what is this bubble here? Hydroxide will form oxygen gas. Okay, reason, why do we choose hydroxide? Why do we choose hydroxide? Because they are lower in the ECS. Do you remember what is ECS? The electrochemical series. Okay, the electrochemical series. Okay, they are lower in the ECS. Okay, lower in the electrochemical series. So number 2, how do you confirm the product formed at the anode? Guys, how do you confirm oxygen gas? How do you know a colorless gas is oxygen gas? We have so many colorless gas. You see, around you, there's nitrogen, there's hydrogen, there's oxygen, there's carbon dioxide. Every gas colorless. How do you know it's oxygen? How can you tell people? How can you convince people this is oxygen? You don't say by smelling it, guys. You don't smell a gas. Bubbles can be anything, can be? You see, I breathe out carbon dioxide, right? Humans breathe out carbon dioxide, right? When you use a straw and blow into a cup of water, you still see bubbles, right? But that is carbon dioxide, though. How do you confirm this is oxygen gas? Carbon dioxide is colorless too. Carbon dioxide is colorless too. So how do you confirm? Guys, oxygen, they really like one thing. Oxygen, they really like one thing. Fire. Yes, fire. So what do you do? What do you do? You use a glowing wooden splinter. This glowing wooden splinter will reignite. Okay, reignite. This kayu uji membara dinyalakan. This glowing wooden splinter will reignite. It will catch fire again. Really easy. You just take any fire, you throw into oxygen. If the fire becomes bigger, then you know it's oxygen. And if it's hydrogen, it will give you a pop sound. Remember? We learned this in Form 2. Hydrogen is pop sound. Right? So what is the... Okay, we skip 3. We don't do 3. Okay, not really your business. So D, For copper electrode, this is the third situation one. State what is formed at the anode and the reason. Anode, I'm choosing neither, girls, right? But instead, copper will jump into the water. Copper will jump into the water. So instead, you will see copper ion. Copper ion, because copper, they become water. What? You see, solid copper is copper. Liquid copper is copper ion. So they jump in, right? And the reason, this is to replace copper ion in the solution. Because like I said, if this is negative, copper comes here and stick here. Positive here, copper will jump out to replace the copper. You kick one out, I jump one in. You kick one out, I jump one in. Situation 3. Okay, so how do you confirm the product? Okay, there's nothing to confirm. You just see reddish brown. You see reddish brown. Okay, we don't do question 3. That's all. Guys, do you have any question? Do you have any question? If there's no question, I shall go to the last part of this chapter, which is 6.2. Which is 6.2. Okay, chemical cell. 6.2, chemical cell. Guys, shall we begin? Shall we begin? This is situation 3 again. Yeah, Kavi, what's up? Oh, you're still writing. Sorry. Okay, this is situation. Are you done? Are you done? So let's go to situation 3. Let's go to 6.2, chemical cell. This is situation 3. Okay, you might say, okay, so just now all we have learned, can you see is battery everywhere? Is battery everywhere? Like I said, if you go back to the first page, so far what we have learned is electrolytic cell. We are using battery to make chemical reaction. Again, we are using battery to make chemical reaction. But now, chemical cell is how we use chemical energy to make electric. I am creating battery now. Previously, all those we learned, we are using battery. Now we are creating battery. Okay, so let's go to battery. This is how all battery comes. This is how all battery comes. And I want you to remember situation 3. I want you to remember situation 3 because it's almost the same. But now you see something really funny. Can you see there's no battery here? Because this itself is a battery. There's no battery here. All right. And can you see two different metals? Can you see two different metals? Guys, I have a question here. Is magnesium better looking or copper? Who is taller? Who is taller? Magnesium, right? Okay, I want you to remember this. The good looking one will throw electron to the ugly one. Because I'm good looking what? I'll throw my shit to the ugly guy. Right? I will throw my shit to the ugly guy. So you see all the negative here, all the electron here. Okay. Guys, ignore this for now. Ignore this for now. So this part is full of negative. This part is full of positive. Okay. And then we do our SOP. So this is solution. H2O. Cut. Positive, negative, positive, negative. So we just follow situation 3. 2 guys in water, 2 girls in water. So who is the uglier guy? Who is the uglier guy? Copper or hydrogen? Copper or hydrogen? Who is uglier? Yes, copper. So what will you do? What will copper do? Copper will come here and stick. Copper will come and stick here. Right? And then this is situation 3, right? Situation 3, right? So I will not choose any girl. But magnesium will jump in. Okay? Magnesium will jump in and this thing will slowly corrode also. Okay? Magnesium will slowly corrode also. Can? Magnesium will slowly corrode. Okay? So this is how a battery works. Okay, guys, I want you to take note one thing. This is the reverse of what we learned just now, isn't it? Just now we use battery, now we create battery. That's why I want you to reverse your charge when you label. This is still negative, this is still full of negative, this is still full of positive, but when you label, when you name them, I want you to reverse the charge. Don't ask me why, this is the rule. This is the rule. I want you to reverse the charge. Okay, I want you to reverse the charge. Ken, I want you to reverse the charge. Okay, huh? Okay, huh? This is how battery works. Guys, this is how every battery works. I don't care whether your battery is this double, triple A battery, whether this is your car battery, whatever battery, they work the same way. You have electrodes, you have electrolyte. Yeah, somehow that's the negative and positive, correct? Guys, you know every battery has a lifespan, right? You know every battery has a lifespan, right? Your double A battery might last for 3 months. Your car battery might last for 2 years. Okay, so how is a battery used up? When this stick is fully corroded. When this stick is fully corroded like this, and this stick is fully stuck with copper, if there's nothing here left, nothing else left here, I cannot throw electron anymore. There's no more electric flow anymore. This battery is dead. That's why every battery has a lifespan. I wait until this thing fully corrode, then the battery is no more. Do you understand now? Do you understand now? Right? Rechargeable battery, they work the same. Rechargeable battery, they work because this thing can fully donate their electron here, and I can use electricity to push them back, which is charging. I can discharge and charge, discharge and charge, discharge and charge. I can keep doing it repeatedly, but still they have a lifespan. Guys, your phone battery doesn't last forever, right? I'm sure when you first buy your phone, the battery is awesome. 4 or 5 hours, the battery is still working. But after years of using it, now your battery is like, it kind of sucks, right? 2-3 hours, then the thing is like almost dead, right? Because now, you know what is the metal they use in your phone battery? They use lithium. Lithium, they corrode slower than magnesium, but they still corrode. That's why they last much longer than normal battery, but they still don't last forever. So as your lithium fully corroded, your battery is dead. Your battery is dead. So this is the bottleneck of the technology we are still facing, right? Why is nobody buying Tesla? Why is nobody buying electric car? Because charging sucks. Charging still sucks. Guys, imagine this: if you buy a Tesla, charging takes, can it go from positive to negative? You mean the electron going back? That is the charging. That is the charging. Every day when you use your phone, electron will flow here. Okay, when this is full of electron, when you charge it, charging is when I push the electron back. I use electricity and push the electron back here so that I can use it again. Right? So every battery has a lifespan. Okay, so until now, we still have no breakthrough in this technology. Okay, this is why nobody uses EV. Okay, you see, guys, if you use a normal car, I'm sure your house still uses a normal car that puts petrol, right? A petrol car is convenient, right? If your car runs out of fuel, when your car runs out of petrol, easy. You just go to any petrol station. You can fill up your gas tank. You can fill up your petrol tank in 5 minutes. Correct? Correct. But if you drive an EV, if you drive a Tesla, you have to find for a charging spot. You have to book the charging spot. Let's say you are in Kedah. If whole Kedah only has one charging station, then you are dead. You have to queue up. And charging will take like 3 hours. Are you ready to sit there for 3 hours to charge your car? No, you don't. No, you don't. That's why nobody uses EV, because it kind of sucks. Yes, EV is very cool. It's very technological, right? It's very techy, but yeah, it's not very nice to use because the charging really sucks, right? I mean, if you use it to go to work, you go to work, you come back, you charge while you sleep, okay. But if you want to go long distance, let's say you want to travel from Johor to Penang, okay, Johor to Penang is around 800 kilometers. If your car can only go for 600, you have to charge halfway. which means you have to stay one night somewhere and charge your car before you continue your journey. It really sucks, right? So we are still waiting for this breakthrough in technology. But generally, this is how battery works, guys. This is how battery works. Do you have any question? Do you find this interesting? Do you find this interesting? Yes, huh? Oh, Gabriel, you finally replied. I cannot see your message, Gabriel. Did your message go up there just now? I couldn't see your message. Okay, so guys, let me ask you, if I take this cup of water away, and I put a lemon here, will this thing work? Will this thing work if I put a lemon? Yes, because lemon is an electrolyte. If I put a potato, here, will it work? Will it work? Yes, as well, because potato is also an electrolyte. There, ta-da! Wow, interesting, isn't it? Pineapple also can, right? Pineapple got acid, man. But I think apple also can, right? Anything that's sour, like potato is not sour, but potato is salty, right? Anything sour, it will work. Can? Interesting stuff, huh? Interesting stuff, huh? I mean, the basics you have learned a few weeks ago, you might say, sir, we learned this for what? I cannot apply this in my life, but I'm sure this can. I am sure this can. Okay, guys, let me tell you another story. Let me tell you another story. Do you still remember Samsung Note 7? Do you still remember Samsung Note 7? The phone that exploded everywhere? Do you remember that? Do you remember that? Okay, you know what happened? Do you know what happened? Okay, that time, Samsung was trying their best to shrink their battery as small as possible. How can you forget? Okay, they are trying to shrink their battery as small as possible because they want to make their battery better than their competitor. So what they did, as you need to shrink your battery, the positive and negative terminal needs to get closer. I'm saving space, right? So as they go closer and closer and closer and closer and closer, so okay, guys, do you know Samsung, they don't make their own battery. They let another company in China to make their battery. So that company actually made a mistake. When they make the battery, they will accidentally make these two pieces touch. When they touch, that's how you create a short circuit, and this thing will start catching on fire. Right? That's the compromise, guys. That's the compromise. You want to make your battery smaller, you are facing a risk of them touching together. So that's what Samsung did. Okay, so that was the first batch. Okay, phone started exploding. Samsung was like, oops, guys, we made a mistake. You know what? We recall your phone. We will replace with a new one. So they asked another company to make the battery for them. And that second company, they made the same mistake again. The two electrodes start touching again. Phone started exploding again. And then Samsung was like, you know what, guys? We will cancel the phone. You send everything back to us. I will refund your money, and the rest is history. Right? So they cancel the phone. They ask you to bring their phone back. They even force you to do it. Because your phone will update by itself. After your Samsung Note 7 updates, the phone is not usable, so that you can return it to them, because they don't want the thing to explode and you sue them. All right, guys, it was so funny. It was so ridiculous. You cannot even board a plane using Samsung Note 7. Do you remember that? Everywhere in the world, they will check your phone before you board the plane. If they see Samsung Note 7, okay, you cannot go on it, because they scared that halfway through the flight, the phone will explode and it will cost them their plane. Right? So guys, you see, battery technology is something that we are still not able to break through. But guys, the hope is not far. Go and search for this solid state battery. This is the next big thing, the next breakthrough. Because some very smart scientists, they say, what if we change this electrolyte to a solid? That's what we call solid state battery. And if this thing can be made, it will charge in a few minutes. Go and read on that. You will charge your batteries in minutes. Imagine if your phone is using solid state battery, it will not explode. It will not explode. It's very safe, and you can charge your phone. You can charge your phone from 0 to 100 in 10 minutes. Think about it. Think about it. I mean, I'm not trying to give you false hope, but that's what we are working on. Panasonic is working on this. Samsung is working on this. Tesla is working on this. If this thing is possible, if we can make this thing, it will be the next breakthrough in technology. So we just need some time. You see, technology takes time, guys. Technology takes time. Like you see, okay, put it this way. You know Avatar? You know Avatar? The movie Avatar? It's made by James Cameron, which is the director of Titanic. All right? He made Titanic in 99. He wanted to make Avatar in 2000, in year 2000, but he couldn't make it because there's no technology. The technology that there sucks. So he waited until 07 or 08 and he made the movie. So we have to wait for technology sometimes. So guys, just pray for it. If this thing ever comes out, it will be the most awesome technology ever. But 50 companies. Oh, you search for it, Kavi? You search for it? Okay. Oh, okay, cool. Wow, this one I really didn't know. You see, you taught me something new again. Right, so guys, interesting stuff, huh? Interesting. I really, that's why how can you not love science, isn't it? Right? Yes, learning the basics is boring, but once you understand the basics and you understand technology, that's freaking awesome. Okay, guys, do you have any question? Do you have any question? Okay, guys, I have no more time now. I have no more time now, but can I have a request? Can I have a request? Please go home and do question 11. Okay, there's not much for you to do actually. Question 11 and question 10. 10 and 11. 10 and 11. Okay, 10 and 11. Because our time is like not too much already. Okay, please go home and do 10 and 11. If you want, I can put the answer in Google Classroom. You can please check it there. You can please check it there. If you want me to discuss next week, also okay lah. I will discuss with you before we move on to chapter 8. Guys, we are chapter 7. I'm sure you have your chapter 7 notes with you. Guys, we are towards the end, you know. We're towards the end. We only have like 9 chapters in Form 5. We are towards the end. And don't worry, the remaining three chapters is going to be easy. Yay! We have finished the hard one. Like I said, this is the killer chapter. If you can understand this, you definitely have no problem understanding the last 3. So yay, you got through it. Well done, guys. Right? So guys, I hope you have a fun day today. I hope you have a fun day today. I hope you have a fun Wednesday. Okay? I shall see you the same time next Wednesday lah. Okay? Have a good one, guys. Have a good one, guys. See you soon. Take care and sayonara. Bye-bye.